Hello and welcome back, class. Hopefully these videos get a little less awkward as I get a little bit more experienced in this. By no means am I a YouTube superstar, so please do not hit the subscribe button. Notice how it doesn't exist. But today we're talking about chemical reactions. Previously we've already discussed atoms and we discussed bonding, but we have to talk about how we can get to those bonds that we've made. So that's where chemical reactions will come in. Yes, things can explode in this process, but unfortunately, we're not going to be doing that today. So what are chemical reactions? Basically, they are when we rearrange or make new substances based on the atoms that we have. Hopefully you remember the law of conservation of matter, stating that matter cannot be created or destroyed, it can only be transformed. In this case, we're taking something that we have, like this molecule here and this molecule here, or this atom here and this atom here, and we're transforming them into something new. Now you're saying to yourself, okay, there's still the letter A and there's still the letter B. True, but before they were separate and now they're together. Hopefully you remember from physical science or IPS, this is a synthesis reaction when you put two things together. You could break something apart, like when we have this A and B that's already together, and now we have two separate atoms at the end. So we call this a decomposition because we're breaking it apart or causing it to decompose as it changes. You could have another situation where you have A and B together, and now C comes along. A really wants to be with C, but right now is in a relationship with B, so that bond has to be broken for A and C to get together and now B to be kicked to the curb. Not all love stories are sad endings like B over here. Sometimes you have two couples that, it makes better sense if they just switched partners. So we call this a double replacement reaction, where this one above was a single replacement reaction. So you can see how we rearrange them. They're all the same parts, but now they're in different spots. And that's the chemical reaction component. Now, typically when you have covalent bonds, like these down here, you're going to have to kind of reform those. You're going to have to break those in order to get it to go. Think about it, you're breaking something, so that's not going to be an easy task. So this is a little bit more complicated than it just this picture appears here. All right, so let's look at the parts that we have of a chemical reaction before we get into the nuances about breaking bonds and rearranging them. Okay, so to have some terminology so we're all on the same page, the left side of these chemical reactions, we call those the reactants. Should be easy to remember because reactants participate in the reaction. They are what's being reacted. You get how it all kinds of stays the same? So the left side here, all of these things, we would call these reactants in the equation. Well, there's an arrow that's pointing away from them to what they're making. Well, we call those things that are being made products because they're being made or produced by this reaction. And another easy way to remember this is think about how the arrow is pointing towards these products. So the reactants participate in the reaction and the products are what's produced at the end, okay? So let's try to apply some knowledge that we just gained, see how well we do. So I'm going to want you to identify the reactants in this equation. You'll have to do this as we go along the year. So I have an equation here, CH4 plus 2O2 is giving me CO2 plus 2H2O. So it should be the left or the right side as the reactants. Hopefully you said the left side of the reactants because then you would be correct. Remember, the reactants participate in the reaction and the products are what is produced, okay? Now, let's think about it a little bit harder. Remember, in chemical reactions, we're breaking bonds and reforming them. So, do we need energy to start? Hopefully the answer to that question was yes. Kind of seemed rhetorical. You need energy to start anything. To start moving requires energy. To start talking requires energy. To start sleeping in an odd way requires energy. You actually burn calories while you sleep. Something you'll learn later in the year. But this energy to get bonds broken is called activation energy. You need this energy to activate this chemical process. All right, so what is that? So let's look a little bit deeper at activation energy. So activation energy is the minimum amount of energy needed for reactants to become products. Okay? if we think about it in terms of a graph, okay, we have energy that's increasing here on the y-axis. We have time that's increasing here. They're calling progress of reaction on the x-axis, but you can think of that as time. You have your reactants, what you start with in the reaction, and your products. Now, what's interesting for a lot of students is things have their own energy already, right? So this reactant already has an amount of energy that's in it. These products already have an amount of energy that's in it. It just happens that the reactant has more energy stored in it than its products do, right? So to kind of give you a visual of this activation energy and help you understand this graph a little bit, think of the reactants as a house and the products as the lumber, the electrical wiring, the plumbing, the concrete, all the stuff if we broke a house apart, right? You can see what we're doing here. So an active reactant here with activation energy, I have a whole house. If I want to break that house apart into its individual pieces, I need to use a lot of energy, a lot of manual labor, a lot of sludge hammers, maybe some other tools, some muscles, really getting in there. I'm going to be sweating a lot to be able to break that house down and get its products, okay? Its individual lumber, its wires, its plumbing, its concrete, its nails, everything out, okay? Now, that energy that I put in, that is the activation energy. The house is not falling apart by itself. I am physically providing the energy for that to work. All right, so something similar with a chemical process. You have reactants that need to absorb some amount of energy to have some energy put into them to be able to become products. Now, why is this important for us and how does this relate to a biology class? Well, you're going to need to know this because of something called an enzyme. Okay, we've talked a lot about chemistry and now we're going to really start to infuse some of that chemistry into biology a little bit more. Enzymes are a type of protein. They have a very specific role. They are called biological catalysts. That's a new vocab word for you. A catalyst is anything that lowers the activation energy, okay? So if we look here at this graph, okay, and we still think of me tearing apart a house. I know I'm not strong enough to actually do it, so don't call me to tear apart a house. Anyway, so if we have our reactants here, our house, I have to put in a lot of energy to break it apart. But if I had something to speed it up, maybe I had like a bulldozer or some cranes or something really cool, right? Some dynamite even, all right? I could actually lower the amount of energy that's needed to get that house to break apart. And that's what enzymes or catalysts do. They don't make anything different. They still end with the same results, but it just lowers the amount of energy that's needed to get it started, okay? So for you, one of the enzymes that you're probably most familiar with is inside your stomach. You have a large amount of enzymes in there that help you break apart food. And that's an important thing because you don't want food to sit in one spot in your body because then it becomes a breeding ground for bacteria and other parasites. So if you can break that stuff down pretty quickly, even the bacteria, you can break those down with your stomach acid and your enzymes in there. You can actually be a lot more of a healthy individual and get those nutrients into your body a lot quicker. So enzymes serve a huge biological role for us. Now, where a lot of students get tripped up. Enzymes are catalysts, yes, because they speed up that reaction basically by lowering the activation energy. It's a lot easier for me to tear apart a house if I have some bulldozers and some heavy machinery than it is for me to do it with my hands, all right? So enzymes speed up reaction because they lower the amount of energy that reaction needs to proceed. But not all catalysts are enzymes. Okay, that's actually where most students will get a question wrong on a test because the district or the state or even me, honestly, is going to try to trick you and put this as an answer choice. And the student will look at it and they'll be like, yes, catalysts are enzymes. All catalysts are enzymes. It's perfect. I know those two relate to each other. I got this. I'm going to get 100 on it. And then you get the answer back and you're like, I'm wrong. How was I wrong? I said enzymes are catalysts. And I said, no, you said all catalysts are enzymes. That's different, okay? So there are different things that can be catalysts. Some metals like iron can be a catalyst, platinum can be a catalyst. They can speed up different types of reactions depending on what it is. But not all of those are proteins, so they're not enzymes. Okay, so a catalyst is something that speeds up a reaction or lowers that activation energy, but enzymes are a specific group of catalysts that are found within our bodies that are biological, all right? So just a couple of review questions to see if you really got the lesson. I'll post the answers to these, and to be honest, you'll probably submit them for me as well just to check, because I want to see how you're doing with this. So what are the reactants in the equation? C6H12O6 plus O2 yields CO2 plus H2O. It's an important formula that'll come up a little bit later too. What do enzymes do? And tell me what they do. And what is activation energy? Honestly, if you can answer all three of those very accurately, gold star for the day, you're doing pretty good. Hopefully these videos, again, get a little less awkward. See you next time.